A three-jaw chuck moves its jaws in or out in exact unison. For larger parts, the jaws on a three-jaw chuck can be reversed. A four-jaw chuck has independently adjustable jaws. It can be used to center parts that are not round. This square part is far off center. We adjust each jaw accordingly and verify that it is centered. After a cut, we can see that all four sides are tangent to the diameter of the cut.
The collet system is extremely useful when there are many small parts that need to be machined. Specifically, if these parts are less than 1 inch in diameter and require fine concentricity.
A successful work-holding device orients a workpiece for machining, clamping the part rigidly so that the maximum cutting force does not disturb the part while cutting. Care should be taken to ensure the clamping force does not deform the part. The work holding for an axis-symmetric workpiece includes, at a minimum, a device such as a chuck or collet. Chucks and collets are rotated by a motor-driven spindle located within the machine's headstock. A chuck holds a part along its outside or inside diameter using 2, 3, 4, or 6 jaws. The pressure with which the chuck jaws clamp the part is variable. Higher pressure clamping is necessary during the high force material removal of an initial turning cycle. Then the lower pressure suits the lower force cutting of finish machining. When turning bar stock, the stock will typically be held with a collet or hydraulic collet chuck during machining. A collet grips the part with split sleeves that tighten against the OD. In preparation for cutting, the stock is pulled through the spindle and collet the required length by a bar puller. The machined portion will be parted off and caught by a part catcher while the bar puller pulls another length of stock out from the spindle. At the opposite end of a workpiece, the machine's tailstock can house a center. The center is a precision taper for holding the free end of a workpiece if needed. A center may be revolving or fixed. A revolving center is known as a live center and rotates with the workpiece under its own power. A fixed center is often called a dead center and remains stationary. Programmable tailstocks are capable of automatically reducing clamping force when machining particularly intricate or delicate areas of a workpiece to avoid damage. Holding a long, slender part between centers constrains all degrees of freedom except about the Z-axis, which is required for cutting. This constraint prevents the workpiece from bending under the force applied by the cutting tool. Additional work support for long and slender workpieces include the programmable or non-programmable steady rest. Large and irregular shaped workpieces may require the use of a faceplate clamped to the spindle.